Hello students, welcome to another video. This is going to be our last video. I am going to be discussing assignment number 29 and a little bit of 30, okay? Just a little bit, because there are some word problems in there we didn't cover. 29 has to do with graphing the quadratics. And then 30 is basically all application problems, just applications. So I will go ahead and reference about 4 or 5 problems from assignment 30, and we'll be done. Hope everything is well, and you guys are staying safe and healthy, all right? So I'm going to go ahead and get started on graphing those quadratics. We're graphing quadratic functions. All right. Now, a quadratic function is typically in the form of f of x equals to ax squared plus bx plus c. This form right here, we refer to it as the general form. And then there's another form you may see called the standard form. F of x equals to a times x minus h squared plus k. Now, this one right here is called the standard form. Sometimes you'll hear me refer to it as the vertex form, all right? So the first thing I'm going to do is focus on the general form, all right? Now, let me pause here because I have to go turn off this computer for a minute. All right, I'm back. Actually, it was the television. I had to turn the volume down on. All right, guys. So let's go ahead and look at the quadratic functions, and we're graphing these quadratics today. So we're looking at the general form. F of x is equal to ax squared plus bx plus c. Now, remember, this is a second degree function because the highest power is 2, okay? The graph of a quadratic is called a parabola. And we're looking at the functions, guys, okay? So the parabola can either open up or open down. So we're going to look at the a value, which is also referred to as the leading coefficient. And that determines whether the parabola is going to open up or down. So a is the leading coefficient. If it's greater than 0, as in it's a positive, when you graph the parabola will open up and look something like this. Some people call it a U shape. Some people see a little smiley face in there, okay? And it really doesn't matter what you see, to be honest with you, okay? Whatever you want to describe it as. Just know it's a parabola. Now, if the a value is less than 0, as in it's a negative, then that means your parabola is going to open downwards, okay? So either you're going to draw a parabola that's going to open up or it's going to open down. The most important point on the graph of a parabola is the turning point where the graph turns from one direction to the other direction. For example, on this one right here, on the left side, you're going down, 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 down. Then you get to the vertex and you turn and you're going up, 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 okay? Same thing with this one. You're going up, 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 okay? The graph is increasing, but once you get to the vertex right here, the graph turns and starts decreasing. Now, Because of the form of some of these quadratic functions, we're going to refer to the vertex as h comma k. This is the most important point on the graph of a parabola. So when you are graphing, guys, it is critical. It is a must for you to find the coordinate of the vertex. Typically, when you're graphing, especially on Math Excel, you will need 2 coordinate points. And one of those coordinate points must be the vertex, okay? This is very important. Now, obviously, if the graph is opening up, the lowest point occurs at the vertex. So we call this the minimum point or the minimum value on the graph. We call this the lowest point. The lowest point on the graph is where you will find your minimum value. Now, if the graph is opening up, that would be your highest point, and the highest point is referred to as the maximum. And you will see questions about this later on, okay? So if the graph opens up, this function would have a minimum. However, if the graph opens down, the function would have a max value, as in the highest point for the maximum and the lowest point for the minimum. There will be lots of word problems referencing max and min values, and we'll address them later. But for now, we're gonna go ahead and carry on. Now, additionally, these graphs are symmetric, okay? They have a line of symmetry. The line of symmetry or axis of symmetry goes straight through the middle, and it intersects the graph at the vertex. Once again, the line of symmetry, okay, or axis of symmetry, I want to write this somewhere. Let me go ahead and grab a different color so I can write this down somewhere. The line, or sometimes referred to as the axis of symmetry, that's a Y right there, okay, intersects the graph of the parabola at the vertex, all right? So because it is a vertical line, it shares the same x value with the vertex. So it needs to be an equation. And the equation is always going to be in the form of, let me go ahead and erase some of this because I need space here. Okay, let me erase this part right here. All right, so the axis of symmetry, guys, is an equation, and it needs to be in the form of x equals to h. Now, why am I putting h here? Because remember, it's a vertical line. It intersects the graph at the vertex. When you have a vertical line, which axis does it intersect? It intersects the x-axis. So in other words, it shares the same x value of the vertex. So whatever the x value of the vertex is, that's the value you use to write the equation of the line or the axis of symmetry, guys, okay? And yes, many of the problems require you to find the axis of symmetry or the line of symmetry. Now, what does a line of symmetry do? Symmetry is all about balance. Basically, what's on the left over here reflects over the line of symmetry. So whatever you see on the left, you will see it on the right. It's all about balance. So the left side will reflect across the line of symmetry to the right side, and vice versa. The right side reflects across the line of symmetry to the left side. So this is about balance. What you see on the left is what you see on the right. For example, if you're looking at the human face, guys, there's a line of symmetry on the human face. So if you were to draw that line directly from the forehead, through the nose, through the mouth, all the way down to the chin, that would be the line of symmetry. So what you see on the left side of the face reflects on the right side of the face. By the way, they say beautiful people have symmetrical faces, like mine, you know what I mean, okay? So anyways, that's line of symmetry or axis of symmetry, guys. So all of these quadratic functions, they have a line of symmetry. All right, now let's talk about how do we graph these parabolas, okay? To graph a parabola, guys, here are some steps. Number one, you need to determine the direction of opening. direction of opening. And what does this mean? We look at the A value. If A is greater than 0, it's positive, it's going to open upwards. It's going to open up. If A is less than 0, it's negative, it's going to open down. This is basic information, and everybody should know this, whether your graph is in the general form or if it's in the standard form. Right now, for the graphing right here, we're just looking at the general form, okay? Now, going back to the step 2, okay? One of the critical points on the graph of these functions, okay? A secondary point on the graph of these functions, of course, is the y-intercept. So we're gonna find the y-intercept. To find the y-intercept, you're going to substitute 0n for x and solve for y. Substitute 0 for x. Well, you know what? Let's go ahead and rewrite that. How about we just say this? We're going to hopefully you guys get it. Let x equal to 0 and solve for y. Or you're just going to find f of 0, guys. Now, when it's in the general form, here's a nice little tidbit for you guys. Let me write it in a different color. When it's in the general form, okay, in the general form, think about it, okay, if it's in the general form, and you've got f of x is equal to ax squared plus bx plus c. If you plug in 0 for every single x, guys, you find f of 0. Look at what you get. Look at this, okay? Just try and follow through with me. B times 0 and then plus c. What ends up happening is this. This cancels out because when you multiply by 0, you get 0. This cancels out when you multiply by 0, you get 0. So what you're left with is f of 0 is equal to c. So in other words, when it's in the general form, the c value is your y-intercept. So you could just eyeball this and figure out what the y-intercept is. And this is the y-intercept as a coordinate point, okay, as a coordinate point. All right, so that's one point. Remember, when you're graphing on Math Excel, you need at least 2 points. So the secondary point is the y-intercept. Now, the primary point, the most important point, the critical point, of course, is your vertex. So now we're going to talk about finding the vertex. We're going to number 3, and number 3 is to find the vertex coordinate. Find the coordinate of the vertex, guys. To find the coordinate of the vertex, we're going to use x equals the opposite of b over 2 times a, okay, to find x. And then once you find x, you're going to substitute x into f of x to find y, okay? So what is the value of the function at this x value, okay? So guys, listen, you use this little formula. This little formula should look familiar to you. That's part of the quadratic formula, okay? X equals the opposite of b over 2 times a to find the x value. And once you find that x value, take that x value, plug it back into the function to find the corresponding y value, okay? So now, once you have the vertex coordinate, the next step is to go ahead and find the equation of the axis of symmetry. And then you're going to use it to find an additional point, okay? So now, guys, once we have all these components right here, we're basically ready to graph, okay? So step 5 is basically to, I have a step 5 right here. We're going to plot the vertex, y-intercept, and then use the line of symmetry to find the reflection of the y-intercept. the coordinate of the y-intercept, okay? We're going to reflect it over the line of symmetry. So now, guys, we just go ahead and sketch the graph. Sketch that graph, sketch the graph. Okay, that was long-winded. So now I'm ready to go ahead and look at some examples with you guys. So I am going to go into assignment number 29 and look at some examples with you guys. I am going to start with a very, very easy one. Okay, and then we'll work our way from there. Let me see, let me find a really easy one, a good one. That is in the general form. Oh, this is pretty. Okay, this one is problem number 6, guys. So for problem number 6, okay, these were the steps. F of x is given as x squared minus 10x minus 5. Okay, so step number 1, you got to determine which direction is this function going to open. Is the graph of this function going to open? Since x squared is positive, the graph is going to open up. It opens up. Next, we're going to find the y-intercept. Remember, the y-intercept when it's in the general form is 0, comma, whatever the constant is. So in this case, -5. Okay, so now we're going to find the coordinate of the vertex. Now, remember the vertex. We got to use the opposite of b over 2 times a in order to find the value of x. So go back into the quadratic formula, quadratic equation, guys. What's the value of a? The number in front of x squared, that's 1. What's the value of b? The number in front of x, that's -10. So now we're going to go into the formula and substitute. The opposite of b is -10, so it's going to become a +10. Over 2 times a is 1. So we work it out, 10 divided by 2, which gives us 5, okay? So guys, that's the x value. Now, once you find your x value, you got to go back in and plug in the 5 into the function, okay? So we're going to substitute 5 into the function. F of, let me use a different color here so you guys can see. F of 5, okay, will equal to, right here, guys, 5 squared. Maybe I should use a different color. Minus 10 times 5 minus 5. Okay, ooh, that's going to be a large number. All right, so I'm going to work it out, guys. 5 squared is 25. 10 times 5 is 50. And then minus the 5. So 25 minus 50 is -25. -25 minus 5 gives me -30. So essentially, we just found the coordinates of the vertex. So the coordinate of the vertex is going to be the x value, which is 5, comma, the y value, which is -30. And we found this by plugging in the -5 in for every single x into the function. We just went right back up here, plugged it in for every single x, and worked it out. All right. So now, guys, the next step is to go ahead and find the axis or the line of symmetry. Remember, the line of symmetry or axis of symmetry is a vertical line that goes straight through. It's imaginary, by the way, it's not part of the graph. It's a vertical line that goes straight through the middle of the graph, intersects the graph at the vertex. So it shares the same value, the same x value with the vertex. So since the x value is 5, this means that the line of symmetry or the axis of symmetry is going to be at x equals to 5, okay? So now, guys, I'm ready to go ahead and graph this one. The only thing is, this is a very, very large value we're going to be graphing, okay? So I am going to do increments of 5s, guys. I'm going to do increments of 5, okay? So these increments are going to go up by 5, all right? So just be careful with that. We're doing 5s, okay? I'm going to keep reminding you. So the first thing I'm going to do is plot that critical value. What's the critical value? The vertex, of course, okay? So remember, all of these are going up by 5. That's 5, that's 10, that's 15, and so forth and so on, okay? So 5, comma, -30. We're going to count by 5. -5, -10, -15, -20, -25, -30. So the vertex would be right there, guys. That's the turning point. That's the critical points. All right. So next, I'm going to plot the y-intercept. Now, this is the y-intercept right here, 0, -5. It's located right about here, okay? Now, here comes the line of symmetry, guys. This is how it's going to help you, okay? We need, when you're sketching these graphs on paper, you need 3 solid points. The vertex, of course, is the critical point. Then you need to plot one of the intercepts. Best intercept to plot is the y-intercept, of course, because not all the graphs have an x-intercept. All right, so we have our y-intercept. So now we're going to go ahead and plot the equation of the line of symmetry. And the line of symmetry goes straight through. It's dotted out because it's not part of the graph, the middle of the graph right there, okay? So now you have the y-intercept on the left side of the line of symmetry. It's located at 0, -5. It's 5 units away from the line of symmetry on the left. So you want to reflect it on the right side of the line of symmetry. So how do you reflect it? You go to the right side of the line of symmetry and count 5 units from the line of symmetry on the right side to reflect it. So guys, now you have your 3 points. You're ready to just go ahead and sketch your graph. So here it is. Okay, look, right there. I'm going to sketch that parabola. And there we are. Look at that. There's the parabola, guys. We have our first graph of a parabola, okay? So on your assignments, you're not going to be doing the graphing. All your graphing questions are multiple choice, so I kept it very easy. I just want you to be exposed to these type of problems. Of course, once you move on to the college, you will be required to graph these, especially in college algebra. But for now, I just want you to get the basics. You have to be able to find the vertex. You have to know what the graph looks like. You have to know whether the graph is going to open up or down. You have to know the line of symmetry. Just the basics, okay, guys? So we've got our graph. Now that we have our graph, you notice the graph is opening up. Since it's opening up, I could ask you this question. Does this function have max or min value? Because it's opening up, the lowest point is right here at the vertex. So this one would be a minimum value. And what would be the minimum value? The minimum value is the y value. So in this case, the y value would be -30. But guys, that's okay. If you could just tell me if it has a minimum or maximum, we're good. We'll address some of these things later. So that's the basics of graphing a parabola, okay? So now what I'm gonna do, guys, rather than sitting here and graphing a whole bunch of them, I am going to go through a few questions from the assignment and go over finding the vertex, okay? I am going to be skipping around because I haven't addressed the vertex form or the standard form. So now I'm just going to go through here and run through some quick examples that are in your assignments that are asking for you to find the vertex, okay? So we'll do another graphing question later. All right, here's number 2. F of x equals to 2x squared. The a value is 2. Remember, we're finding the vertex, okay? The a value is 2. There's no x, so the b value is 0. And if you go into the the formula, x equals the opposite of b over 2 times a, well, b is 0, guys. So 0 divided by anything is just 0. And if you take that 0, you plug it in, what do you get? You get 0. So the vertex of this one is going to be at 0, 0. Okay? It's that easy. Seriously. It's not that difficult, guys. All right. Next one is problem number, remember, I'm going out of sequence. Problem number, let's see here, 4. Okay. Number 4 is very similar to number 2. It's f of x equals to 6x squared plus 3. Well, once again, you have an a value because that's critical. It's a quadratic. You must have that a value. But there's no x term, so that means b is 0. So this is just like this problem up here. So if b is 0, a is 6, okay? You plug it in, x equals the opposite of b over 2 times a. That's going to give you 0, okay? So now you take the 0, plug it back in to find your vertex. So 6 times 0 squared plus 3, that's going to give you 3. So the vertex of this one is going to be at 0, 3. All right, guys, we did number 6 already. So I'm moving on to number 7. And remember, I'm just going through these and finding the vertices, all right? F of x equals to negative x squared minus 6x minus 5. Again, A for this one is negative 1. B is negative 6, okay? So now we're going to go ahead and go into the formula. X equals the opposite of B over 2 times A. So this one's going to be x equals to 6, because that was a negative. It becomes a positive, the opposite of it, over 2 times A. A is negative 1. So you get 6 divided by negative 2. And 6 divided by negative 2 gives you negative 3. So this is the x value of the vertex, guys. Now we're going to find the y value. Be careful. You're substituting in a negative. So I can see you guys right now doing this. No, 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 don't do that. Negative times negative positive. No. Okay, if you're not sure, put it on your calculator. Minus 6 times negative 3 minus 5. So to simplify this one, you keep the negative, square the negative 3, that's 9. Negative 6 times negative 3, that's 18, and then minus 5. So negative 9 plus 18 is 9. 9 minus 5 gives you 4. So there's the y value. So the vertex of this one, guys, is negative 3, comma 4. Not bad, okay? I think I'm gonna do maybe one more, okay? And then I will stop. Remember, guys, when you're graphing these parabolas, you must find the vertex. Vertex is the turning point. It's the most important point on the graph of a quadratic. It's the critical point. All right. So this one, A is 4. Oh, by the way, this is number 8. B is 8. So we go into our little formula again. X equals the opposite of B. B is 8, so it becomes a negative. Over 2 times A. A is 4. So we're going to simplify this. Negative 8 divided by 8 gives us negative 1. So now we take that negative 1 and substitute the negative 1 in to find the value of f of negative 1. So we do 4 times negative 1 squared plus 8 times negative 1 plus 6. Negative 1 squared is positive 1. 1 times 4 is 4. 8 times negative 1 gives you negative 8 plus 6. Now, 4 minus 8 is negative 4. Negative 4 plus 6 gives you positive 2. So, guys, the vertex for this one is negative 1, comma 2. And there you are. Not bad, not bad, not bad. Okay, so now I am going to chat a little bit about the standard form. Okay, this is just another way of writing the quadratics. Now remember, I'm just barely surface teaching this, I'm just giving you the basics for you to be somewhat familiar with these quadratics, okay? So if you can look at the form and determine that this is a vertex, standard form or a vertex form, I'm good with that. Standard form, sometimes I refer to it as vertex form, as you just heard me allude to it, okay? Because, guys, I'm going to tell you why we refer to it as vertex form. If you have a function, a quadratic function in the form of a times x minus h squared plus k. Once it's in this form right here, you don't have to do any work to find the corner of the vertex. It's just h comma k. And guys, yes, it is that easy. You can essentially eyeball this and figure out the corner of the vertex without doing much work. How easy can it get, okay? I mean, the A is still there. If it's positive A, it opens up. If it's negative A, it opens down. It's still the same thing. You know, to find the Y-intercept, you still have to plug in 0 for X and solve for Y. But here, this is a focus on finding the vertex. So once it's in this form right here, guys, it is so easy to find the corner of the vertex. Okay, I know some of you don't believe me, so let me show you. Here's one thing you have to remember though. You got to do the opposite of this one. You see how it was a negative here, and over here it's a positive. You got to do the opposite. Here, let me use a different color. Okay, you got to do the opposite of what's inside the parentheses. This has to do with transformations. I remember talking about transformations with you guys way back when. So if the value is inside the function, it moves the function in the opposite direction. If it's outside the function, like the k, it moves it in the same direction, up and down, inside, left, right, opposite direction, okay? So guys, let me show you how easy this is. This is problem number 5 from the same assignment. It's f of x equals to x plus 9 squared plus 2. Now, the question is simply this. What is the corner of the vertex? Shazam, look at how easy this is. Look at how easy this is, guys. Look. Okay, so I'm going to do the opposite of what's inside the parentheses. It's a positive 9, so it's going to become a negative 9, comma, the value on the outside, positive 2. And that's it. That's it. That's it. Okay? It's that easy. All right. So if you missed that one, let me go ahead and do another one. Let me see here. I'm going to find another one, guys. Hold on a sec. I'm looking for a different one. Okay, I can't find one at the present moment. I didn't want to get to this one yet, but I'm just going to go right back to it. And this one right here is early on in the lesson, and I skipped over it because there's a little complication here, all right? It's number 3. Number 3 is g of x equals to x minus 8 squared. That's it, okay? And they want you to find the corner of the vertex. Now, this one you need to be careful with it. Why do you need to be careful with it? If you notice, there's nothing outside. So the graph is not moving up or it's not moving down. Where is it at? It's on the x-axis. And on the x-axis, what are the y values? All of them are 0. So the y value is 0, but you got to do the opposite of what's inside the parentheses to get the x value of the vertex. It's going to be positive 8, 0. Guys, look at how easy that was. That was so easy, okay? Some of the questions on the assignment are that easy. You just eyeball the function and figure out the corner of the vertex. Okay, so here's another one. This one requires a graph. It's number 22. They give you this function right here. F of x equals to negative 1/4 of x plus 6. Now, if they were to ask you to, let's say, graph this one right here, okay? I'm going to go ahead and go through the graph. First, we need the corner of the vertex. What's the vertex? The opposite of what's inside the parentheses, negative 6, comma, the value on the outside, positive 2. Look at that, okay? So now, we have to determine which way is this parabola going to open. Guys, right here, it tells you which way the parabola is going to open. This is a negative. The leading coefficient is negative. So therefore, the parabola is going to open down. Now remember, we need an additional point to graph this parabola. By the way, we have enough information to find the axis of symmetry. So the axis of symmetry is an equation in the form of x equals to whatever the x value of the vertex is. So in this case, the x value of the vertex is negative 6. So therefore, the axis of symmetry is going to be x equals to negative 6. Remember, the axis goes straight through the middle of the graph and intersects the graph at the vertex. Because it's a vertical line, it's going to be in the form of x equals 2. And since it intersects the graph at the vertex, it will share the same x value with the vertex. All right, guys. By the way, you have enough information to be able to decipher which one of the 4 answer choices is the correct answer. But I'm just going to go ahead and graph it anyways. Now, since I'm doing it on paper, I need the y-intercept. Why am I writing axis here? The y-intercept. Remember, you got to plug in 0 for x and then solve for y. So I'm just going to substitute 0 in for x. Okay. I'm going to go in here, plug in my 0 for x. Let me use a different color so I can plug in that 0 there. Okay. Right there, guys. I'm going to plug in my 0. Okay. That's the substitution. And then I'm going to go ahead and continue solving it. Plus 6 squared plus 2. All right, let's do some work, guys. 6 squared is 36. Okay, so now I'm going to take a quarter of 36. In other words, I am going to take 36 divided by 2. We're multiplying negative 1/4 times 36. That's the same thing as negative 36 divided by 4. Negative 1 times 36 is negative 36. Negative 36 divided by 4 is negative 9. Negative 9 plus 2 is going to give us a negative 7. So guys, the coordinate of the y-intercept is going to be at 0, -7. Shazam. Now, some of you may be looking at that 1/4 and asking, hello, what does that 1/4 do to the graph? How is this going to affect the graph? And you're right to ask that question. It does affect the graph. That value, that leading coefficient, determines whether the graph is stretched vertically, okay, or if it shrinks vertically. Stretches and shrinks. You can stretch it or shrink it vertically, depending on the leading coefficient. By the way, since it is a value that is less than 1, it's going to shrink. That just means it gets closer to the x-axis. But that's advanced stuff. That's beyond the scope of this class. We're going to leave it right there, guys, and you guys can pick it up later in college algebra, okay? So now, let me go ahead and graph, guys. Let me show you this beautiful graph. Hold up a moment. I am going to erase all of this so I can graph it. Guys, on your problem for number 22, you have plenty of information to graph it. So I am doing all of this like the last part I just did. You don't have to do any of that. Why? Because it's multiple choice. So you don't have to. Okay. -6, 2. 1, 2, 3, 4, 5, 6, 2. Right there. There's your vertex. Okay. Now, ooh, Shazam. Okay, I'm gonna have to redo this one, guys. Okay, I'm gonna tell you why I'm redoing. Okay, because I need more space on the left side, so I'm just gonna go ahead and redo it. Okay. All right. So let me go ahead and re-sketch the XY plane here, because I need a lot of space. All right. All right. So that's much better. Okay. So now let's go ahead and start again, guys. And I'm going to show you why I needed more space. -1, 2, 3, 4, 5, 6. And the vertex is right there. Now, the y-intercept is at 0, -7. -1, 2, 3, 4, 5, 6, 7. Right there. So here's why I needed more space. My line of symmetry, let me use a different color and sketch it, is right here through the middle of the graph. Okay, so this point right here is on the right side of the line of symmetry, 7 units away from the line of symmetry. So I'm going to have to count, I'm going to have to count 6 units, actually. I said 7. 6 units from the line of symmetry. I'm going to have to count 6 units to the right, guys, to get to its reflection. 1, 2, 3, 4, 5, 6. So there's a reflection of the y-intercept. That's why I needed to sketch a better graph. All right, so here's my graph. All right, there's that beautiful graph. So now, guys, that I have my beautiful graph here, another question could be, okay, does this graph have a max or min value? Well, the graph is opening downwards, so the highest point is occurring right there at the vertex, and since it's the highest point, we say that this graph has a max. What is that max value? The max value is the y value at the vertex, so in this case, it would be at +2, y = 2. And that's it, okay? So now, guys, I am going to, I think you have sufficient information to be able to get through the multiple choice part of this. So what I want to address next are some of the word problems. Oh, wait a minute. I just saw this little problem right here. Okay, so let me address these two right here, and then we'll adjust the word problems. Because I know most of you are having a difficult time with the word problems because I gave you a lot of word problems. I love quadratic application problems, okay? So number 16, guys, it is simply asking, given this function right here, f of x equals to -3x², there's a negative right there. Is this one going to have a max or min value? That's all. That's all you have to find out. Does it have a max? Does it have a min value? Okay. So how do we know if a graph has a max or min value? We need to decide if the graph is going to open up or if it's going to open down. What determines that? The a value. So you look at your a value. In this case, it's negative. Because it's negative, the graph is going to open down. So that means you're going to have a high point at the vertex. So this one is going to be a max, okay? And then problem number, that was number 16. 17, guys, is the same thing. F of x is equal to 9 plus 4/5 x squared. It's also asking, does it have a max or does it have a min value? Again, here's your x squared term. Look at the leading coefficient. Look at the value. Look in front of x squared, guys. Is it positive or is it negative? It's positive, so the graph is going to open up, and since the graph is opening up, the lowest point is at the vertex, so this one would have a min value. And that's it for those questions right there. Okay, so those questions are very straightforward, very easy. Now, let me go ahead and address those word problems. And they are starting with number 11, talking about max and min. Shazam. Listen carefully to this one, guys. If a baseball is projected upward from ground level with an initial velocity of 64 feet per second, then its height is a function of time given by s equals to negative 16t squared plus 64t. What is the maximum height reached by this ball? What's the maximum height? Look at the operative word in there, guys. What is the maximum? So they want you to find the highest point. Where do you go to find the highest point? At the vertex, okay? So how do you know whether it's the highest point, where the highest point is at? Well, let's look. You look at your function here, your equation. The leading coefficient is negative. So when you graph it, the graph is going to look like this, okay? And you know the max of the min occurs at the vertex. And because the graph is opening downwards, it's going to have a max value. Now, x would represent the time it takes to get to the maximum value. And then s would represent the maximum height, guys. And that is what we're looking for, s, the maximum height. So guys, let's do it. In order to find the maximum height, we have to find the coordinate of the vertex. Because the equation is given in the form, in the general form, you have to use the formula x equals the opposite of b over 2 times a. Now, in this formula, a is negative 16, b is 64. So we go into the formula and substitute 64 for b, negative 16 for a. So we get negative 64 divided by negative 32. You want to simplify this. Negative 64 divided by negative 32, that's 2. So guys, at 2 seconds, okay, this is what this is saying. At 2 seconds, okay, the ball will reach its maximum height. But that's not the answer you're looking for. You're looking for the actual maximum height. So how do we figure it out? Well, figure out where the ball is at 2 seconds. So you're going to take that 2 seconds, plug it back into the equation for x. Okay, so let me erase a little bit here so I can do the substitution to find the value of s. So I'm going to go into the function. Let me use a different color here. And I'm going to substitute the 2n for t. Okay, remember the 2 represents how long it takes for the ball to reach its maximum height. 2 squared is 4. 64 times 2 is 128. 4 times negative 16 is your negative 64. Negative 64 plus 128 is 64. That is the maximum height, guys. And feet, they give you this. It's going to be 64 feet. Okay, that's your answer. Be careful. All right, now this next one, guys, is a 2-part question. This is problem number 12. The cost, C of x, in dollars of manufacturing X bicycles is given as 4x squared minus 1200x plus, ooh, Shazam, I'm running out of room here, 101,000. Part A, it says, find the number of bicycles, all right, that must be produced to minimize the cost. Minimize, as in minimum, guys. So you're minimizing. And how do we know it's a minimum value? Because the leading coefficient is positive. So when you graph it, the graph is going to look like this. So the lowest point is going to go at the vertex. So in other words, guys, they want us to find x. X represents the number of bicycles, okay, to minimize the cost. So how do we find x? Because the formula is given to us in the general form. We're going to use x equals the opposite of b over 2 times a. Now in this formula, a is 4, b, be careful with that, is negative 1200. Be careful. So we're going to go into the formula. We're going to do the opposite of b. It's the negative 1200. It will become positive 1200. And we're going to divide it by 2 times a. So 1200, we're going to divide it by 8. Now, what's 1200 divided by 8, guys? Let me go ahead and throw this into a calculator. 1200 divided by 8 gives me 150. So 150 is part A. You have to produce 150 bicycles to minimize the cost. Okay, that's the answer to part A. Now, part B, they want to know what's the minimum cost, okay? So when 150 bicycles are produced, what is the cost to produce those 150 bicycles? How much is it going to cost to produce 150 bicycles, okay? That's the question, guys. So let me go ahead and go back to this function, and we're going to plug in 150 for every single x in that function. So we're going to do 4 times 150 squared minus 1200 times 150 plus the 101,000. All right, so let's grab those calculators and plug all this in. Be careful when you're plugging in the value. 4 times 150 squared minus 1200 times 150, and then plus 101,000, and comes out to 11,000. Let me use a different color here. All right, guys. So when the function reaches its minimum, okay, there are 150 bicycles produced, and it costs 11,000 to produce those 150 bicycles, okay? So part A is 150 and part B is the 11,000. Be careful when you're typing in these answers, okay? Now it seems like problem number 13 is the same problem. What? Yeah, it is. Oh, okay. 12 and 13 are exactly the same thing, guys. So I'm gonna bypass number 13, moving on to number 14. And for number 14, I've got, let's see here, find 2 numbers whose sum is 82, whose product, remember, is multiplication, is as large as possible. Hence, let x and 82 minus x equal be the 2 positive numbers. So you got 2 numbers, guys. Find the sum of 2 numbers whose sum is 82 and whose product is as large as possible. So their product can be described by the function f of x. This is all in the hint, is equal to x times 82 minus x. So this is the function that has been created for you. Now, based on the functions you've seen already through this lesson, you haven't seen one like that. So you need to distribute the x and see what happens. Distribute that x. So you get 82x minus x squared. Now, guys, I am going to rewrite this in descending order of powers. The x squared will come first, but it's a negative, plus 82x. So there's your function. It's a quadratic. It's negative leading coefficient, so which means it's going to open downwards, okay? So you're going to have a maximum value at the vertex. So the problem is simply asking this, okay? At what x value is has this function reached its maximum, okay? So guys, we're going to use the formula again. X equals the opposite of B over 2 times A. The B value is 82, so that's negative 82 over 2 times negative 1. So you get 82 divided by 2, so that's going to give you 41. X is 41, okay? But wait, there's more. You got to find the other value. This is the first number. Remember, there's 2 numbers we're looking for. So how do we find the other one? Remember, one of them is X. That's this one. And the other one is 82 minus X. Well, if one of them is 41 and the other one is 82 minus 41, well, 82 minus 41 is just 41, guys. Okay? So in other words, when the function has reached its maximum, okay, to get the product to be as large as possible, both values must be exactly the same. So 41, 41, okay? The 2 numbers are both 41. And just like that, we're done. Now, for number 15, it says find 2 numbers whose difference this time is 62 and whose product, unlike the previous one that was as large as possible, is as small as possible. So what do you think we're going to be looking at? We're going to be looking at a minimum problem, guys. So f of x equals to x times x minus 62 is the function that is given. You distribute the x, you get x squared minus 62x. There's your function. Obviously, x squared is positive, so you're going to have a graph that looks like this. So the lowest point is at the vertex. So just like with the previous problem, let's go to work. We're going to find the corner of the vertex, pretty much. So x is equal to opposite of b, which is 62, over 2 times a. A is 1. So 62 divided by 2 leaves us with 31. Now remember, we're looking for x and x minus 62. Now think about it, guys. If the first value is 31, okay, we want a secondary value. So we're just going to take that 31 and plug it in. So when we work it out, we get negative 31, okay? We want the product to be as small as possible. So if you were to take that 31 and you multiply it by negative 31, guys, yeah, that's going to give you a really, really small value. And I'll tell you exactly what it is because I am plugging it into the calculator, negative 961. Yeah. Okay, unlike with the previous one was 41, and that was as large as possible. If you do 41 squared, guys, that one is going to give you 1681, okay? So for this particular problem, guys, be careful. One of them is positive 31, and then the other one is a negative 31. So be super careful when you type these in, okay? Positive 31, negative 31. Here, let me write this down for you guys, okay? Positive 31, negative 31 is the solution for this one. So be careful when you're doing these problems. Let me see if we have any more word problems in this assignment, because I think, people, we might just be done with this assignment right here. Absolutely, I am. And as promised, I was gonna go into assignment number 30 and do a couple of word problems in there. Actually, it's a few, I'm not a couple, because there are some in there that I think you guys are having a difficult time with, maybe because I didn't go over this lesson yet. So now that I've gone over this lesson, you should be okay with it. But just in case, I'm still going to go over them because this is our last video and I want to make sure I cover everything with you, okay? Because the word problems, you guys typically have a very difficult time with them. All right, so I am going to start with, I'm going into assignment number, let me see here, 30, the last assignment of the school year, guys, last one, number 30, okay? And I'm going to start with problem number 5. It looks like I'm going to do about 3 or 4 of them. Number 5, the other ones I've already covered them, okay? They're in previous assignments. So for number 5, it says one positive number exceeds another one by 4, and their product is 96, okay? So let the first number be x, So the second number would be x plus 4 because it says one of the numbers exceeds another one by 4, okay? So if the number that you don't know anything about, the first number, we call it x. The second number would be x plus 4. Now it says, by the way, positive numbers, okay? Positive numbers. Ooh, there's thunder outside. It's gonna start pouring. Okay. Anyways, their product is 96. So in other words, if we take these two numbers right here and multiply them together, x times x plus 4, the product is 96, guys, okay? So they want us to find the numbers. Be careful. They want us to find two positive values, guys, positive numbers, okay? So we're going to distribute. We get x squared plus 6x equals to 96. This is a quadratic. We got to set it equal to 0. Move that 96 over. X squared plus 6x minus 96. They want positive values. So for this one right here, we want to factor this, guys. We want to find two numbers that multiply to give us 96, negative 96. And then when we go ahead and add them together, we get 6. What are those two numbers right there? Let me see here. What would be the two numbers? Now, if you're stuck on this like I am, you guys could go ahead and use the quadratic formula. But I just found my numbers, okay? The two numbers that work, that multiply to give you negative 96, and then when you add them together, you get 6. They're positive 12 and a negative 8, guys, all right? So this is where you need to be careful. Why? Because you want positive numbers. Now, for this one right here, what number plus 12 makes it 0? Negative 12. We're going to eliminate this answer, okay? Reject that answer. Why? Because it's negative. We're looking for positive, so can't be negative 12, okay? Don't put that negative 12 in there. However, for this one right here, what number minus 8 makes this parentheses 0? 8. So 8 minus 8 makes it 0, so therefore, yes, 8 is a solution because we wanted positive values. So we got one of them, okay? This represents x. The other one represents x plus 4. So in other words, add 4 to this, and so it would be 8 plus 4, which gives you 12. So the answers are 8 and 12, guys. Positive values, no negatives, guys. I think that's the trick with this question. You got to be careful. All right, next one is problem number, let's see here. That was number 6. While hovering near the top of a waterfall in National Park at 5,184 feet, a helicopter pilot accidentally drops his sunglasses. The height h of t given after t seconds is the following function. H of t equals to negative 16t squared plus 5,184. When will the sunglasses hit the ground? Oh, I love these questions. You guys know when the sunglasses hit the ground, what's the height? When the sunglasses hit the ground, guys, the height will be 0. So all you're doing is taking negative 16t squared plus 5184 and setting it equal to 0 and solving it. So you subtract 5184 from both sides. So this gives you negative 16t squared is equal to negative 5184. Divide both sides by negative 16. So you get t squared. Grab your calculator and do your little division here. 5184 divided by 16 leaves me with 324. And then we take the square root of both sides, guys. Remember, this is time. All we care about is the positive value because time is only positive, okay, not negative. So it's going to take 18 seconds for the sunglasses to reach the ground, okay? So be careful with that, guys. And then I think this is the third one I'm doing and probably the last question I'm doing. By the way, many of these word problems are going to appear on the test, guys. The test is already uploaded for you. All your assignments for the remainder of the year are up, okay? So here comes number 7 in assignment number 30. W of x is equal to 0.5x squared, gives the number of servings of wedding cake that can be obtained from a 2-layer X-inch wedding cake. What size square wedding cake tier is needed to serve 288 people? The length of one side of the square wedding cake tier is how many inches? Okay, now the W of X represents the number of people it's going to serve. So we're going to take that 288, okay, because we want to serve 288 people, and set it equal to 0.5x squared, the equation, and solve for it. So we divide both sides by 0.5, okay? I mean, you can go ahead and grab your calculator and throw this on the calculator, guys, but this is very straightforward. It's 576. And then you want to go ahead and take the square root of both sides. Take the square root of both sides, okay? So when you take the square root of both sides, remember, what are we looking for? The size of a square wedding cake. So if you're looking for the size of a square wedding cake, it can't be a negative value. It has to be a positive value. And by the way, this is in inches. So this one is going to be 24 inches, okay? So the length of one side of the square wedding cake is going to be 24 inches, guys. And just like that, guys, I am done. This was the last video of the school year. And guys, can you believe it? We're practically done with the school year, okay? So hopefully you learned something in this video. And obviously I'm not going to see you next time because I don't have any more videos. But guys, that's it. Just do your assignments, okay? I'm done.